Welcome again, and thank you for joining our open mic off the records live demonstration on StableNet basics and in particular fault management here at Infosim. My name is Nieke Aerts and I'm a senior research and development consultant within Infosim, and I will be moderating today's event. Joining us from our headquarters office in Würzburg is my colleague Hendrik Degener, senior consultant and developer within Infosim. Good afternoon to you, Hendrik, and a very warm welcome to the webinar.
Thank you, and good afternoon, everybody.
Before I hand over things to Hendrik, I have a couple of things I want you to know. First of all, you are muted when joining our audience in order to keep down the background noise. During the first part of the webinar containing the live demo, this will be the case. When you would like to ask a question, you have to raise your hand via the GoToWebinar application, and then you will be unmuted by us. This part of the webinar is being recorded, and all of you will be notified tomorrow via email, including a link to this recording. The second part of the webinar will be an open mic Q&A of the records, so you can ask us any question about StableNet directly in the voice chat. This part will not be recorded. That's all from my end so far, so I would like to go ahead and hand over control to Hendrik. Hendrik, are you ready to take over?
Yes, I am. Thank you. So then, let's start with the presentation. So that's me. And we will now come to the agenda. So first of all, I want to tell you a little bit about the StableNet architecture, their interfaces, and so on, and give you also some information about our company. Then I will do the live presentation of the fault management, so you get a good idea of what that means when you're dealing with StableNet. And at the end of our session, I will provide a few hints on where to find additional StableNet resources, and before that, of course, your questions and my answers. So then, let's start. So I want to give you a little background information about our company. Infosim was founded in 2003 as a project spin-off from the University of Würzburg. We are a privately owned company servicing customers worldwide. Our main product is a unified network and services management solution called StableNet. Our company headquarters is here in Würzburg, Germany, and this is also where all development is taking place. But we also have offices in Singapore, Austin, Texas. And about 100 employees worldwide. So StableNet is the one application that is able to deal with all your network and services management tasks, no matter how complex your network may be. It includes powerful and fully automated discovery, performance, fault, configuration, and services management. StableNet is provided as one application with one underlying data structure and one database. It is vendor agnostic and offers solutions across different platforms and technology. All of StableNet has been developed by Infosim directly at our headquarters in Germany. We have never acquired any source code or programs from other companies. Well, except for some graphical libraries, because no one needs to reinvent the wheel. The StableNet architecture is quite simple. StableNet server, the middleware, holds all functionality modules and manages the connection with the database. It is also responsible for data aggregation, reporting, and visualization. As you can see in the left area of this diagram, StableNet provides several client interfaces, from the classic rich client to the web client. That works on all major browsers, and of course, we also provide a mobile app for those users who are on the go. With a highly configurable and flexible northbound interfaces, you are able to connect and exchange data with, for instance, umbrella applications, a CRM, or an inventory database. To the north, so the instrumentation layer, you see the StableNet agent. This is the so-called workhorse within our software that talks to the devices and fulfills tasks like measurements that I will deal with today, and also other tasks as configuring, backing up, and dealing with services. The StableNet agent runs as software on a number of hardware platforms, from small inline devices to powerful appliances. It is, of course, available for both Windows and Linux-based operation systems. Depending on the hardware, these agents can deal with up to several thousand devices and way over 100,000 measurements. They are also able to communicate with each other in order to provide additional information, like, for instance, detailed end-to-end visibility. The agents are connected to the StableNet server, but will work independently if the connection is lost due to a problem with the network or other problems. The collected data will be delivered to the server once the connection has been re-established. This server agent concept allows StableNet to scale up or down as needed. We have customers who only use a handful of agents, while others have as many as tens of thousands of agents in use, all depending on the individual IT infrastructure requirements. And for those of you who are waiting impatiently for the live demo, this is the last content slide. So the demo is coming up in less than 1 minute. But let's have a quick look at the available interfaces for partner or customer extensions. As you can see, we offer a variety of protocols, scripts, and other methods used to exchange data with northbound or southbound systems, services, or devices, which actually leads us right into the live demo, as I will show you now, where we will use some of those interfaces and deal with with thresholds and all the fault management area. So let's dive right in and open StableNet. So here it is. And when talking about the fault management area, we are often talking about events, we are talking about thresholds and time. And all this is managed by our so-called monitors. The monitors are watchdogs for data coming into the system. This is the example configuration of one monitor. We can see that it is that it deals with the average round trip time of the device that we can see here, the Uturna device. And it has a name, a description, but what's more important is below. It's the monitor severity that you can control for every monitor. It ranges from informational over minor to critical. You can set it active or inactive, which means will I get an alarm or will I not get an alarm? And then we have our thresholds in right here. So what we can see is that the thresholds are between 0 and 2000 milliseconds, which means, as also visually indicated here, that everything is green or okay if the value coming in is between 0 milliseconds and 2000 milliseconds. What we also have is this little button here called Expert Settings. And here you can see the interesting features as the grace time and the probation time. These time settings are related to scenarios where there might be a peak, where this monitor might exceed the 2000 milliseconds, but this might be just a one-time event and not a real alarm. And the grace time now specifies how long the monitor will wait until it raises an alarm. So if the data it comes back to normal in 5 minutes, there will be no additional alarm in the system that your NOC has to deal with. The same vice versa. Once the monitor is gone into the alarm state, it needs, so the data coming in needs to be in the green corridor for at least 5 minutes before the alarm vanishes from the system. I will, there are other settings that are also important in very special use cases. I will show you one, or I will talk about one setting. This is the sticky alarm setting. This means that if this is enabled, the monitor will not automatically go into the green state again once it has entered the error state. This is important for cases when there are so one-time events, like you're reading an event log, and the event that is read once, and on the next run the event is already gone, but you do not want to lose the alarm state. So that's for cases like this. So event log, general log file monitoring, or something like that. Okay, so that's what a monitor does. But the monitor relies on data, and the data is now an interesting part. So how does the data come to the monitor so that the monitor can react on it? This is done by so-called measurements in StableNet. So measurements are the actual items that are elements that are executed by the agent, as I already told before. The agents in the system, just for you to know, I have one agent on this system, and this agent executes measurements. And we have many different types of measurements. So you can you have an overview of all the different measurement types in here. But I will just quickly deal with the different areas. So we have IP SLA measurements. Ping can use the Windows Management Instrumentation interface for Windows Server monitoring, can do TCP connects to check for service availability, for example. We can use SNMP, which is a very flexible and very powerful mechanism for obtaining data. We can use flow, such as JFlow, SFlow, NetFlow, and so on, and can also check on data coming in from there. We can use own scripts that that you can also reuse your already available script that you might have from other monitoring solutions, for example. And we can also deal with syslogs and traps. So let's take a look at a configured measurement. So this, for example, is an availability measurement, which is a ping measurement. So if we take a look at it, okay, so we can see its configuration, we can see which device it connects to, we can execute it and check what's coming back. So ping responses, as you might would expect it. And do some more configuration for this measurement. And this measurement exposes data, and this data is what is sent, so to say, to the monitor. This data is what the monitor acts upon. And if we take a look at the data that came in by this monitor, we can see, okay, it's been pretty low in here. You can see the green area is the threshold, that's the okay area. So it's a very, as it is a local connect in this case, so we can see, okay, the milliseconds are 0, which is okay, according to the monitor settings. But if the value that's coming back is breaching this area, then we will get a so-called alarm that will appear in here. So as we can see here, we already had some alarms in here. So we can take a look at the history. So this looks a little different. So there was some stuff going on in here. But let's quickly take another alarm. And so I think you get the concept. The measurements are providing the data. The monitors are the watchdogs that act upon this data. Taking a look, for example, at this one, we can see, okay, there's a state that's monitored. We can see, okay, that's 2 is warning and 4 is shut down. And as you can see in the red corridor, that everything between 2 and 4 resembles an alarm. And that's also what happened here, because we got a state of warning. So, but what I showed you is our SNMP measurements, which means, so in this case, an SNMP measurement, and in the other case, a ping measurement, which means the agent was executing the measurements according to their schedule, as you can see here. Like every 5 minutes, the value, the Cisco power supply internal, is queried. The data is obtained. The monitor checks the data if it's in the right or wrong state. And but these are, so to say, active measurements, because StableNet is actively querying or polling the respective device. But what about syslogs or traps? So the measurement concept of StableNet also deals with syslogs and traps. So we have active measurements and passive measurements. On this machine, for example, I have set up 2 measurements, one for syslogs and one for traps. So let's take the syslog measurement first. What can I configure here is the name, the description, some other information such as the start date. So when does the measurement become active? We will deal, so the interval in here when it comes to syslog or trap measurements is the auto clear interval, which means if a syslog comes in and according to the syslog filters specified in here, the syslog is treated as an alarm event, then it will clear automatically after 5 minutes, unless I configure a different behavior. But you will see about that later. What we can see in the filter section is that we can filter on the syslogs coming in. We can check on the facility, on the severity, on we can provide a down expression. So which here I can state, okay, what specifies an alarm, so to say, and the up expression tells me when I can clear an alarm that is available in the system. So this is if a device sends a syslog, service XYZ is down, and like 30 minutes later it sends the up expression syslog service XYZ is back again, then I can automatically clear, so StableNet automatically clears the alarm from the system, and the alarm vanishes from the below table. Okay, so that's the basic behavior of a syslog. So let's test it. For this, we can use this PowerShell command, for example. So what I will do is I will send the syslog message to the agent, which is the syslog and the trap collector. I will use the severity of critical. I use the facility user, and the message, we will not use clear for now, but error, so that we get an error in the system, because as you remember, we have the syslog filter. This is a regular expression, so do not wonder that there is an asterisk and a dot in here. So which basically means if the syslog message contains the word error, there will be an alarm for this filter configuration. So let's see what happens when I send this. So now the syslog will enter StableNet. So the agent first. The agent will then process the respective syslog and apply the configured syslog measurement configuration. And it should also soon be available in the syslog entries that you can see here. Because, which is very nice, in the StableNet GUI, you will find the current syslog entries, so the recent syslog entries that have entered the system, filtered on the selected node. So I can see here that this syslog was correlated to the device that is related to the syslog sender, which is this is the device that I'm currently running on. I've sent the syslog from here. and StableNet now knows, okay, the syslog belongs to this device. That's why I will show it in this context. If I take, for example, this one, I do not find any syslog entries because there are no correlated entries for this device. If I want to see every syslog device, syslog entry, this also holds for trap entries, by the way, I can select the root node. Then I will see all the syslog entries that have recently entered the system. And what I can also see now is that this syslog now raised an alarm. We can see the alarm. It's also selected in here. So if I select the alarms direct here, then the monitors, sorry, then the respective alarm will also be selected in the below table. So which is a very good feature, so that you do not have to search for the connection between the two. Okay, and now we can see some more information. If I double click on the alarm, and we can see, okay, that's the syslog that entered the system. So that's pretty nice. I can also see, okay, that's my error message. It came from PowerShell and so on. This is some information that's coming from the syslog. What I can also do is I can specify the result format. So I have some placeholders in here that I might add some more information or tweak this a little bit so that the displayed message will, so this has influence on this message and also on this comment that's generated in here. Okay, now we have an alarm in the system. So it's it has a time when it came in, and now your NOC can deal with it. What you can do is you can, for example, clear it, which means it would the monitor would go back to green and the alarm would vanish from the system. But you can also acknowledge it, which means, okay, the alarm will not leave the system, but somebody has taken a look at it, and it is known that, so the alarm is now known. Yeah, I can also reverse this. I can directly schedule a maintenance based upon this alarm, which comes in handy if the whole device is broken down. Then I can schedule a maintenance so so that everybody knows, okay, there is something going on the system. There's some maintenance going on right now. Okay, but what happens if yeah, but I will deal with more sophisticated alarm handling in some minutes. What I want to show you now is how the traps are handled in StableNet. So because it's very similar. Here again we have our measurement that's that's able to handle the respective trap. Again, we can specify filters. We can specify, for example, a community filter. We can configure some other settings like, okay, do we want to specify an OK trap that's able to clear the respective trap? If we want to filter on the device correlation that I have shown below, even down to a respective interface if we are checking interface traps. And yeah, on the next page, we can even filter more on the var bindings of the respective traps. So, but let's test it. Let's send a trap to the system so that you can see what happens if such a trap enters the system. So this is my trap. I will send right now with via this command line interface, and same as the syslog, it will soon enter the system. So let's just wait for a second until the system has correctly refreshed in the background, and then we can see, okay, the respective measurement has reacted on it. So what we can see now is that we have again the trap entries in the system. So this is how it came, how StableNet got it, which means, okay, there is some OID to the left. It has the respective value. So we have one var binding in the trap. So we can see the type, severity, source, and so on. So that's pretty nice. As you can, as you get more information on the trap, and you are now able to maybe refine your trap measurement, do some filtering, maybe cold start, warm start, authentication failure. These are the defaults, but you can also, you're free to also enter your own OIDs and so on here. Do filters on the var binding. Maybe the OID whatever contains or equals error, for example. So then this measurement would only, or the respective monitor for this measurement would only raise an alarm if all those filters are matching for the respective trap. But I have to do much by hand if I set up this this measurement. So what's also a very nice shortcut is I can right click on it, and then I can say, okay, create a new trap measurement. So this shortcut enables me to just save time, because I can directly react upon the trap and create a measurement right out of the trap area. So what I can see here is that there are some values that are now predefined. So the trap severity, we can see normal, and it was normal. That's why we also have the severity filter set to normal. The community was public from the trap coming in, so we have it also in here. We can define some more detailed behavior using this, these two settings, but I will not dive into those settings right in this session, because it's a little too detailed. I will try to stay, or to dive not too deep in. And then we can see, okay, this is my this is the OID that this trap is related to. And now I could also enter other filters or additional filters, as I've shown you before. But I could also say, okay, just press OK, and that's it for now. Then I have the trap measurement into the system, and then as you can see, okay, this measurement does not yet have a monitor, which means, okay, it would collect data about traps coming in and matching this, filter settings, these filter settings specified by the measurement, but it would not create an alarm. So you could open the analyzer to explore certain values of the respective trap measurement, which, for example, the rate where respective traps are coming in, so to detect if there was some kind of a message storm, so to say, and to detect peaks. But of course, you can also create new monitors after you've created measurements. And the type below, you can see, okay, which data or KPIs can I act upon. It's the trap state, which is the default monitor for traps, for example, which means, okay, 0, everything's good. Everything else is bad because we have an alarm, according to the measurement specification. Certain other values, but we will, we could stick to this right now. Click the respective monitor visits to the end, and press OK right on the end, and then we have a new monitor in here. So that's how you handle syslog and trap measurements. What we have seen now is that this trap measurement that was in alarm state before, because I've sent an error trap, has now gone back to green. So I said before is that this is due to this clearing interval. If you do not want to have auto-cleared so you do not want to auto-clear the respective alarm, then you can specify an OK trap filter. So this OK trap filter then specifies what has to happen so that this alarm is removed from the system. So the OK trap filter is similar to the alarm trap filter. You specified the respective OID like this, certain filter settings yeah, this can do numeric not calculations, comparisons, other Boolean types of expressions, and yeah, such as contains. So maybe clear, something like that. And then once I do this, the respective alarm is then cleared using a trap. So we can configure this real quick for this trap measurement. So let's copy this, the OID from here. So I'm too lazy, so I will do it quickly right like this. So then I will use the alarm trap, and okay, everything that comes from here is an alarm. And now I will specify my OK trap filter, which also reacts on this one. And I will soon enter the other filter. I have to look up the value, the OID value. Okay, so I will now quickly copy this value. And for the OK trap filter, I will say, okay, if my if this value binding matches clear, then this will be back to normal. So let's quickly check if this is okay. So we will specify a little bit better. So we will use error for this, for the alarm, and clear for the up trap. Okay, so this looks pretty good. So let's test it. What I will do now is I will send the error trap once again, prepare the clear trap, just wait a short moment. So we have seen, okay, this has entered the alarm state. It will also now not leave the alarm state unless I manually clear it. I can also manually clear alarms using the right click on the respective monitor and clear monitor alarms. So this is also an option. But if you want to clear it using an up trap, I've now entered the clear in here. So let's wait for a short moment. So you have seen, okay, it has entered the green state because the trap, the clear trap that we can see here, has entered the system. And also this matched symbol gives you an idea if there was a measurement configured in the system that matched the respective trap. Same with the syslog. And as we have measurements configured that are listening on the respective, or where the filter settings apply to the respective syslogs or traps, yeah, those ticks are in. Other unhandled traps and syslogs would not have this tick. Okay, so that's for the syslog and traps. And now we can go a little bit further and take a look at at auto actions in the system. So maybe we want a mail to be sent once an alarm comes in. So let's take, for example, this device. So auto actions can be defined on the monitors. So if I modify this monitor, we can see the tab where the auto actions can be defined. They can be defined via so-called alarm notification groups. So in this webinar example configuration, I have specified that the monitor priority is does not matter. I could use a different value if I want to use if I'm using monitor priorities, which is a different topic. But I can also filter, for example, on a minimum monitor severity. Maybe I do not want the mails for marginal alarms, but only for for major alarms, for example. So I could specify it like this. And then for every monitor that is a member, as you can see here, of this alarm notification group, the same behavior would be, so to say, executed. So what I can see here in this area is what I define for the respective alarm notification group. I can define what happens in alarm case, which means, okay, I want to send a mail address. I might also want to execute a script to trigger some business logic or whatever. So, but this is a more advanced use case, so I will not drill down into that topic. But let's stick with the mail, for example. I have the possibility to define the target mail address. I can also edit the mail message that comes in. What we can see here is that there are lots of placeholders that you can use. So these $ish placeholders are evaluated and replaced once the mail is about to be sent, and you have a little wildcard table below, so where you can see all the available wildcards. So you have lots to choose from, and can thus add context information about the respective alarm that this mail is sent upon. So we will leave it like this for now. I have it, I prepared it a little bit so that it looks like this. And before we can actually send a mail, we have to, of course, configure our mail server that this mail is, that sends the respective mail. We can do it in the options and in the mail server properties right here. So what I've used is this mail server. I'm using the simple mail transport protocol on this port. The mail sender email address will be StableNet@infosim.net. And just to test it, I will send a test mail for now. So what's the destination email address? Maybe let's take an arbitrary mail address like webinar@infosim.net. So then you can see, okay, the test mail has been sent. Check if you have received it. Then we can check the respective mail client. I'm using a fake mail server and mail client for now. It's called, it's the mail slurper, so to say, and you can see, okay, that's so that the time reveals it. Okay, we pretty much advanced in the time. Okay, I have to hurry up, and you can see, okay, that's the test mail contents. So which means the mails are, the mail integration is working. We can send mails. So now, as we configured this monitor, I will show it again, to be in this alarm notification group, we could test if what happens when we create an alarm and the respective mail is then sent out. So let's do it. Let's manually create a monitor alarm to test the alarm notification group. So once I have done this, there will soon appear an alarm in the system, and there will soon appear a respective mail in my inbox. So you can see here, okay, that's my alarm. You can see, okay, that's me. Who is the system owner? The affected device is this one with the respected IP, because I have used the respective wildcards to show this information. The subject that I have specified, and so on. So this works. So let's quickly clear the alarm so that it comes back to green. What's also possible is a ticket system integration, so that you can directly right-click on a respective alarm and create a ticket directly from the context menu. But this is a topic that I just wanted to tell that this is possible, but that's a more advanced topic, so I will not cover the details in here. What's more interesting is the deduplication of alarms. So because so you can see we have many monitors in the system. So to see what's, for example, configured for this device, I could use the monitor table in here, which shows me all the monitors below this node. So just as a shortcut, the selected item is also selected in the tree. So we can see, okay, these are 20 monitors. Now, if the whole device breaks down, every monitor would normally go into the alarm state, which because every monitor, every alarm belongs to exactly one monitor, would yield about 20 alarms. So, but as we do not want this, because we actually want only one, that the device broke down, it's very nice that StableNet handles this automatically using its built-in root cause analysis. And the root cause analysis is a mechanism that uses a dependency graph in the back. So, which means that every monitor has monitor dependencies, and the monitor dependencies define the root cause, the respective root cause setting. We can, it's very nicely available to see it on this system, for example. So let's take this Intel system. We will quickly explore its neighborhood. So, which means, okay, which devices are my direct neighbors? Which I have none right now. Sorry for this. Seems like somebody has taken care of messing this up. But normally, let's take this switch, for example, that should have a neighborhood of certain devices. Okay, we only know of the London dependency, but that's okay for now. So the connectivity, so this topology is automatically created while StableNet is discovering your devices. So which means these two devices are connected, and as this is the main switch on our side, if this one breaks down, this item, so the whole London device will not be available as well. And so the actual root cause will be the breakdown of this device, and this London device being not available, all the monitors going into alarm state will only be a symptom of the whole thing. So, and all this, these information, these pieces of information, StableNet automatically detects while during the discovery. And using this information, StableNet then builds a dependency graph. And such a dependency graph might look like this. So this this monitor, for example, has lots of possible root causes, which means, okay, if this monitor goes into alarm state while one of those monitors is in alarm state, this will be just a symptom and not an own alarm. So let's, I would say, let's quickly test it. So as one possible root cause is the average round trip time of this device. So let's check what happens when I actually trigger an alarm and set the mess with it, so to say. So let's check the configuration real quick. Let's check that we have okay, the grace time is set to 1 minute. That's okay. Let's quickly check the intervals so that you do not have to wait too long. And okay, so what happens now is, or what I will do now is I will trigger an alarm and see what happens. So I will now just invert the settings so that everything what was green before will now definitely be red, and I will also do it right here. So let's do it really quick. So just to show you the root cause analysis. And now we have to wait for some seconds. And in the meantime, I can show you a different feature because it's okay that you can react on events coming in from various sources, but in the end, you might only be interested in your SLAs. And getting your SLAs out of StableNet is pretty easy using our group analyzer. And the group analyzer has a statistic and a report type that's called monitor availability DNA, which is showing you a DNA chart of the monitor availability over the last 1,440 full minutes, which is a day. If you you can also set it like to 1 day, then you would get the last, so from 0 a.m. to 0 a.m. from the last day. Okay, so what you can see here is that we have a certain availability information about monitors. So we have chosen a top 10, which means it shows me the top, the least best, the worst performing monitors, the top 10 or maybe the top 15. So I can see it in the DNA chart, but what's also pretty nice is that I can see it in this table. So I can also get the tabular version of it. I can see, okay, the availability of the respective monitors. I can set also top N to 0, which gives me all the data of all my monitors in the system. What I can do here is now creating this link. When I click on it, I get it presented in my browser, but I can also copy this link. It's tokenized, so you can see it right here. So there's a token in it, so you do not even have to log in once you open this link. And you can give it to your respective admin, your customer, but you can also use it, for example, for scripts or something like that. Okay, in the meantime, the root cause analysis has taken place. As you can see here, these are our 2 monitors that I have manipulated to create alarms. And what you can now see is that you do not have 2 alarms, but only 1. So you can see it here. It's this 1 alarm. Average round trip time, because according to the monitor dependencies I've shown you before, that's a possible root cause. And it's correlated to the respective alarm, but only as a symptom. Symptoms are hidden by default. You can easily show them using this right-click menu, and then I can see it. And the integration with the tree, you can see it. Okay, that's the corresponding monitor. And if I would now, for example, add other monitors, so let's say this one, I would set it to inverted as well. It will then be correlated under this 1 root cause as well. So you get the deduplication you would expect, and you are also free to manipulate, for example, these monitor dependencies. I could, for example, add another root cause in here from the respective tree. So like this, just add another one if StableNet has not automatically detected the dependencies that you want, and so you can manipulate it. And you can also do it, for example, via our XML discovery. So everything that I've shown you before, creating measurements and creating monitors, manipulating thresholds and manipulating all other settings, you can do all this using our XML discovery. So it's not a manual task that you have to apply on like thousands of elements. So, and so according to the grace time settings, this monitor will take a little longer to go into alarm state, but it will eventually be correlated under this root cause in here. Yeah, and that's the basics in fault management. You can also ease your task and bring some more visibility into the whole topic using our dashboards that you can see on the right. So here you have some information about alarms in the systems, the highest severities, about which alarms have been acknowledged. So maybe let's just acknowledge this one. So this should then soon be reflected in this chart. So we will have one acknowledged alarm in here then. Status of the respective monitors or of devices, so that you can see, okay, this is a device, and every device gets the most critical alarm state as its device status. So you can see, okay, even though I have 7 alarms in the system, or actually 8 with one acknowledged, you can also see, okay, this number has changed here. The respective graph has been updated. And you can see even maybe I have 20 alarms in the system, but actually the only affected devices are 5. So that's a very interesting information. Right-clicking on it also reveals the monitor table to show me all my all my related monitors to this chart. Of course, I'm free to add other dashboards, to create new dashboards using our dashboard management system. So I can easily create a new dashboard using what you see is what you get editor. For example, I could add webcam content in here. I could add tables and other graphics and also other chart types. So I can do lots with those dashboards, but of course, we do not have any more time to deal with this. So, and now I want to end my short live demo of the system. And yeah, I want to quickly say thank you for you to stay with us for the time being. And yeah, I think now it's time for the Q&A session.
Thank you, Hendrik, for the session. I would like to thank everyone for joining us today. As I have mentioned earlier, a recording of this live demo part of the webinar will be made available to all of you tomorrow via email. So please stay with us, because we're going to go to the off-the-record sessions soon. Hendrik, do you have a final remark for the recording?
I don't think so. Thank you again.
Okay, thank you again. Our next Global Webinar Day will be on May 24th. In case you are not on our invitation list but would like to receive those invites, please send an email to newsletter@infosim.net. And thank you for joining us, and enjoy the rest of your day. Goodbye.